Okay, today's problem is 399 evaluate division. I actually haven't solved that problem before, but previous try was not successful. Previous recording try, I mean. So I already read the problem statement and have a couple thoughts how I can solve it. So let me read it again and I'll show my approach. Okay, so the problem is about equations, given equations and the values for the equation, and a couple of queries that are similar to equations, but we should answer whether I should answer whether this query is solvable with the given input values. So let's say we have a B, B, C values 2 and 3. So it means A by B gonna be 2 and B by C gonna be 3. And I need to find A by C and B by A and A by E. A by A and X by X. So A by C can be derived by multiplying A by B and B by C. So 2 by 3 gonna be 6. B by A can be derived by division B by A. So it's gonna be it's gonna be 1 over 2, so 0.5. So A by E is not present in the input, so it's gonna be -1. A by A, so A is present in the input like variable A, so it's gonna be 1. And X by X, oh, even though like X by X should be like 1, but because the X is not present in the as a variable in equation, the output should be -1. So if I copy this, let me show you what I think about how this should be solved. So let's assume we have these values and this queries, and, and this is expected output. So my idea is here to do the following. This equation can be represented as a graph, as a directed graph, and the variables should be basically vertices and like the presence of connection between two vertices is so basically as an edge between two vertices. Say I have like A here vertex and then B here vertex, and because A by B gonna be 2.0, I'm gonna create an edge, and the value of the edge gonna be 2, 0, and the backward link I'm gonna divide it, so it's gonna be B by, so this one is A by B equal 2.0, and B by A should be 0.5. And then I'm gonna add another vertex C, and the link between B to C gonna be B by C equals 3, and backward C by B gonna be equal 1/3. And then the queries. So A by C, I need to find query A by C equals question mark. So A by C basically means that I should start at A and end at C, and if there is a path between A to C, then it means that I can calculate that path value. If there is no path between A and C vertices, then it means that I should return -1. And also, um, there is a trivial path from A to A, something like this. It's going to be 1, and trivial path between B and B, 1 also, and trivial path between C and C gonna be also 1. And it means like C by C. Let's say I have this A by C, so I need to find a path between A to C. So I have a graph represented as let's say hash map with a string key and hash set string value, and this one gonna be key, and the value gonna be the hash set uh, of the connected vertices keys. So A by C, I start at A. I find it like in O of 1 because it's a hash map. I find by key A and start my path here. And let's assume I do BFS. And by doing BFS, I traverse through this graph and I record the interim result. So I do A by B, and this is um, all vertices reachable from A, and I store the path A by B, gonna be 2, and I also gonna save it to the result. It's gonna be result gonna be equal to, and then I do the BFS another iteration from B, where I can travel from B. I can travel to A, but A is already visited using this back link. Or I can travel to C. So A by B, A by so gonna be result by C, and gonna be equal to so if I traverse, I multiply 2 by 3. So 2 by 3 gonna be 6, and the result gonna be final because I started from the A, I ended with C, so I can find the A by C, and A by C result is stored in the result, and I save the output. So the complexity of the time complexity of BFS. So it's gonna be I assume V plus E, something like that, where the V is the vertices and E is number of edges. And if let's say I have assess the time complexity here, so the equation length is maximum 20. So it's gonna be path maximum 20. Um, so it's maximum like 20 edges. So edges uh, reach 20. Multiply by 2 actually, and then what the queries 20 queries length, okay, and I is equal to what? They don't give I. Okay, queries length maximum 20. That's pretty. So 20 by 20. What's number? Oh yeah, 20 by 20 like 400, not that much. Okay, so what I'm gonna do? I'm gonna start solving that using BFS. So here I have values, I have a list. So I'll create a graph, and graph gonna be hash set, and here gonna be a string as a key, and hash okay, hash map here, and hash, let's say hash set. I wanna store a string here, but the problem is that I need to also to save the value for the edge. So let's say can I save, let's say I want to have private static class pair, and then I'll have public string var pump string. Actually, I can save the edges. Yeah, I can probably save the edges information in the. So I can save it next to the actual connected vertex, or I can do the following. I don't want to deal with this hash map or like hash code for the new class. So I'll have this uh, hash map string and then float and then edges equals, let's say, call e equals new hash map, and then g equals new hash map, and then for int I equal in, let's say I want to have like equations list string equations from the equations uh, again also int I equals 0 I less than equations length or like size I plus plus, and I do the g if g dot get equations, let's say string var1 equals equations get I get 0, string var2 equals equations get I get 1, and then if I cannot get the var1 from the graph, I'm gonna insert g dot put new, let's say I wanna have hash set string neighbors equals g dot get var1, and then if neighbors is null, I need to put new, okay, neighbors equals new hash set string, and then g dot put var1 neighbors, and then neighbors dot get dot add var2, and then I want to add this edge dot add dot put I want to do this var1 plus divide plus var2, and then the value is actually values dot I, yeah, values dot I, and I want to do the same for the reverse. Hash set neighbors2 neighbors2, so I want to do var, okay, change it neighbors1 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 neighbors1, and then neighbors 2, neighbors 2, neighbors 2, here var 2, var 2 over var 1, or 1 over values I. So this is saving the structure for the graph, and then I need to do BFS for this. And if there is a path between for the every query, if there is a path between query I0 and query I1, I should put the output into the array, and like output is gonna be like the multiplication of edges that connect start and end based on the query. And if there is no path that connects to edges to vertices, I should return put the -1. Or if there is like a pretty trivial case, if there is the vertex exists and there is like vertex by vertex query, I should put 1. So I should go private double, double. Let's say also save here double. Here, okay. Double. Neighbors 2, neighbors 1. Double BFS, and then I want to have this list string query, and then I want to have this edges, and then I want to have this graph. Say I want to first have this here, so the graph gonna be passed into the BFS as a second parameter, and the edge is gonna be passed as a third parameter, like this. And then I'll have also a hash set probably of visited vertices. So let's get the list string source equal query get 0 string this, let's say source destination gonna be query dot get 1, and then I'm gonna check if source equals destination. Let's say if h.get no g.get source not equal null, I should return 1, else return -1. Okay, and then I'm gonna create the queue, let's say double result equal 1, equal 1, okay, 1, and then queue string queue equals new linked list, and then let's say I want to have hash set string visited equals new hash set, and then until queue that offer source, and then visited add source, and then I want to do while queue is empty, while queue is not empty, I want to do this queue.all, and queue.poll, and then I want to do this hash set string neighbors. I want to do this also queue string queue vertices and queue vx and vl values, and here gonna be double, and then I'm gonna offer queue vertices will offer this one, and queue value dot offer 1.0, and then queue dot poll string vertices equal queue vertices queue dot poll string value queue value dot poll, and while queue vertices not empty, have neighbors equals g dot get v if neighbors equals null. I'm gonna continue, else for neighbor in neighbors I wanna do I wanna first get the string expression equals value plus divide plus neighbor, and then double multiplier, let's say double mult equals edge dot get expression, and then I wanna do the following. I wanna do the if v dot equals destination, that say we wanna have query destination here, q dot equals q if current vertex is equal to destination, just return the value, and then string expression get multiplier, and then I wanna do that value multiple, so q dot offer let's say visited add neighbor, and then I want to do that q dot vertices add like offer neighbor, and q dot value dot offer value multiplied by multiplier, and then if the BFS ended, I wanna and I have not returned anything, I wanna return -1, something like this. 25th minute. Let me make it smaller to check if I missed anything in the algorithm. So first I'm gonna create this graph and I just save the edges values. Um, then I'm gonna run PFS with breadth-first search. It should be. Equations. Okay, so for the equations, why is it complaining? Neighbors one. You don't get. Okay. String var two. Mm, okay. Okay, so I need to go for int I equals y. Let's say for the every query, double uh, result equals new double, and then queries size, or like yeah size, and then for I equals 0, I'll then queries let's say res that size, uh, length y plus plus, and then result I is equal to BFS BFS queries dot get I, and then G, and then E, and then return result. Mm-hmm. I forgot to include if not visited. Um, if neighbors, if visited contains, then continue. Yeah, that's it. So it's like 29 minutes. There was a small typo. I forgot to include the visited. Check. So I will mark this as a fail actually because I had the chance to review the algorithm, but I was rushing towards like submitting before like 30 minutes pass. Um, so I'll mark it as a fail, but let me check what they have here. So this one is basically DFS, depth first search for this one. Union. Okay, that's it must be interesting. Parent ratio. So instead of saving just saving just union find this array, they have this parent and ratio, build the union find union. I got it. So it's like relation to the parent, no? Let's say we choose the parent and we find whatever the ratio for the parent. Let's say we decide A is gonna be, oh, okay, so it's like it's flat structure. Yeah, it's gonna be interesting to solve this with union find and with this approach. I'll probably think about this. What time? Let me run the code. So the calculate equation. So they on every equation they calculate the graph. That's weird. Or calculate equation is the main function. Okay, so they create a graph and they call evaluate, and evaluate is visited. Do they have visited? Oh, seen. Seen is basically what? Seen is, I don't know what's seen. Variable here. How I can scroll it to the left? Okay, seen is a set. Hash set. Guess Leetcode lost. Okay, I can scroll it, but there is no down scroll here. There is this weird scroll, scroll and scroll. Okay, probably because I changed the zoom. Yeah, no, not really, just bug. So it's DFS. Is there any BFS that has a good one? Time complexity. Textra. Okay, yeah, even more complicated. calculate equation, create a graph, visited, queries, recursive, okay, DFS, stream. I wonder if those people gonna solve it on the real coding interview with like the streams, etc., etc. That's definitely like a lot of code here and there. Edge. So this is what was I talking about? So the list here, but like how it's gonna uh, if there are duplicates, let's say duplicates for the nodes. I guess they just don't care because in the problem statement it says probably that there is no duplicates. So you see that. They don't say about anything about um, duplicates. So in the worst case scenario, it's gonna be like another edge duplicate of the edges, and yeah, it can be difficult. Yeah, but I think that it's gonna be like a fixed cycle, something like that. And it's again, it's DFS. Okay, let me try to do that again. My solution. Yeah, I'm gonna wrap it up. So as I said, the status is fail because I forgot to include this visited check here. And that's why I was receiving time limit exceeded exception in the Leetcode with Leetcode judge. So that's it.